Okay, this is Unit 3, Part A. We're talking about measurement basics. So Lesson 1 is talking specifically about mass. So it says the circular plates on the ends of a barbell have been calibrated, which means measured to be a specific mass. So for example, if this is a 10-pound barbell, you got 5 pounds on each end, and you're lifting your weights, right? So that's called mass. So mass is the amount of material that an object makes up, so solid material. So for example, the stapler I'm holding up, if I were to weigh this, this is how much the mass is. Mass is how much it takes up, how much it weighs, okay? All right, now it says the mass should not be confused with weight, though, because weight, we do refer to mass. Mass doesn't change from place to place. So if I were to say to you, what is the mass of this stapler? Is the mass of this stapler going to change if I put it in Mr. Breitenbach's room? No, the mass of this is going to stay the same. So mass remains the same. However, weight can change. So that means, yeah, I know, I got to just get bigger. Just keep getting wider. So yes, weight can change. Mass never does. So you have to remember that with the objects. So an object's mass will never change, but weight can. So we have mass. We're talking about the amount of mass on the moon. So it says, for example, the moon is approximately 1/5, which is 20% of the mass of Earth. So the moon is 20% of the Earth's mass. That's what that's telling us. So it says a weight of an object on your moon would be 1/5 less, okay? Or sorry, would be 1/5 in comparison. So it says the amount of matter is the same. So for example, if I were to say to you, I'm taking this stapler and I'm taking it to the moon with me, how much this stapler weighs is different from the mass. The mass is how much this object is made up of. Okay, so the mass is not going to change here or on the moon. However, the weight of this, how heavy it is, will change on Earth compared to the moon. On the moon, this is going to be 80% lighter. That's what that's telling us. Okay, so we're going to make a big note here. On the moon, the mass is still the same. Right. Objects weigh. This is the difference. Objects weigh 80% less, but the mass stays the same. Okay, make sure you write that down. So no matter what, if the weight changes, that's fine. Your mass will never change. Okay? So weight changes, mass stays the same. Now we're going to talk about the metric system in terms of our conversions. So measuring mass is going to be in kilograms. Okay? So measuring mass is in kilograms. Now there's a few little words here we have to understand. We've got milligrams is the smallest unit. So what they show here in the staircase is the smallest unit on the bottom and the largest on top. So if you were to add extra staircases to this, you would add 3 more stairs before you get to the word ton. The word ton is 1,000 kilograms, which means it's 1,000,000 grams. Okay, so that's a big one we got to remember. Okay, we're going to show more of this on the next page. Turn your page. So it says ingredients and medications are measured in milligrams. Cereal is measured in grams. It says a tractor trailer vehicle often measures things in tons. So therefore, we need to be able to convert. Okay? This means we need to be able to convert between the measurements. Okay, so we got to be able to convert between all of the measurements. Okay, so write that down and then we'll do the examples on the bottom. Okay, so we have a few examples. It says shipping factories Shippers of factories that produce many types of products. Okay, so we want to refer to our staircase and we're going to convert. So what we want here, it says, how many does 25 grams represent in milligrams? It wants milligrams. So if we look at our staircase, I'll just draw a quick one here. So the top, we've got kilogram. Actually, we're going to need tons at the top. So 9 stairs. We're going to put tons on top. Whoa, a little smaller. Okay, tons on top. We don't need that stair. We don't need that stair. And then we got kilogram, hectogram, decagram. There's grams. So these are the staircases we need for this one. Okay, the 3 we need to know: grams, kilograms, and tons. Okay, those are the 3 we need to know. Okay, so now we've got our staircase. We want to convert between all of those. So if I look down here and I've got the rest of my staircase, I've got decagram, centigram, and milligram. It wants grams to milligrams. So I'm going from the middle of my staircase right here down to the bottom. So I'm going 1, 2, 3 stairs down. The number of stairs is the number of tens, or you could remember it as the number of zeros after the digit 1. So this means you're dividing by 1,000. Or sorry, you're timesing by 1,000. We're going down the stairs. Okay, so we're going to times by 1,000 because we're going down. So whenever you're going down this staircase, you're going to multiply, and each step is 10. So you can remember it as however many stairs you go down, the number of stairs represent the number of zeros. Okay? Now let's take a look at B. B says kilograms is what I want, and I'm starting at grams. So for my second one, if we take a look, I'll get rid of this example here. So my second one, I'm starting at grams, and I'm going all the way to kilograms. So I need to count the stairs. I've got 1, 2, 3 stairs. So 3 steps, and you're going up. So that means you're going to divide by a 1 and 3 zeros. The number of steps represents the number of zeros. Okay? So since I'm going 3 steps, that's 3 zeros, a 1 and 3 zeros. Okay. Now letter C, it says how many tons does this many kilograms represent? So now I'm going kilogram, whoops, on this one, I'm going kilogram to ton. So I'm going from almost the top, so middle top to the very top. So that's 1, 2, 3 stairs, another 3 stairs, and I'm going up. So this is 3 up. That means it's going to be a 1 with 3 zeros. And since we're going up, we're dividing. So this is a divide question. So that means we're going to have 16.9. So what they've done is they've taken this number and they've divided it by 1,000. And that's how they've got their final answer, 16.9 tons. So that's what they're actually doing. Let's take a look at the last example in this case. It says, how many grams does 2 tons represent? So I'm going from the very top stair down to grams. That is 6 stairs down. So I'm going 6 and I'm going down. So that means I'm going to times by a 1 with 6 zeros. Okay? So we multiply by a 1 and 6 zeros. All right, write those down, please. All right, measuring mass. It says truck drivers have to keep track of the amount of mass in their vehicles. That's why we have vehicle weigh stations, because carrying too much mass on the roads can damage the roads. So that's why those big trucks always have to pull off and get measured. So it says small amounts of mass can be used on a balance scale. So this is a balance scale. It says to measure the mass of an object, you place the mass on one side and the object on the other. And you keep adding tiny masses until the balance beam is literally balanced. Okay? So it says a standard mass is an object that's already been tested and certified. Just like those weights and barbells and dumbbells, they're already pre-measured to know exactly how much they weigh. Okay? Turn your page.
I did already.
Okay, so it says new balance scales, new digital ones are replacing those other balance scales. So now we have digital balance scales that actually can measure the mass. So if you look at the other one, it says mostly commonly used scales at home measure weight. Weight is according to the gravitational pull. That's something important to know. And it uses grams or kilograms. And you can also measure in pounds. Okay, they also measure in pounds, so kilograms or pounds. So we are going to be learning in the next couple lessons how to convert back and forth to pounds. So what we're doing in this lesson is being able to convert back and forth from on the gram scale on this staircase. Okay, that's what lesson 1 is about, is learning the staircase. Okay, this concludes lesson 1.